and I'll simply do rise divided by run. Remember, the gradient tells us how many steps up per every x value across. Does that make sense? So every x value I go across, how many steps to go up? Remember, we read left to right, so if it's going uphill, Jake, what does that make it? If it's, yeah, very good. If we're going uphill, when we read left to right, it's positive. If we're going downhill, it's got a negative gradient. Clear? Happy with that? I've tried to do different things, but I think that's the easiest way to remember, because that's the part that gets a lot of people. A lot of people confuse the negative and the positive, and that's very common. So just always go back to, is it going uphill or is it going downhill? For our intercepts, a lot of us were struggling initially with finding our intercepts with our equation. The reason we were struggling is because we didn't go back to understanding what occurs at our intercepts. Every y-intercept in the history of y-intercepts has occurred where? I've got no values on this Cartesian plane, correct? What can you tell me about this point here? There's no values on it, but you can tell me one thing about that point. It's the x-intercept, but what can you tell me? You can tell me something about a number. You can tell me that y equals 0 at that point, correct? So at every x-intercept in the history of x-intercepts, y is equal to 0. Now remember, with these linear equations, we can let x or y equal whatever we want. We can't let both equal whatever we want. We can let one equal whatever we want and then rearrange, sub and rearrange, correct? So if we let y equal 0 and rearrange to get x by itself, that will tell us our x-intercept. And if we let x equal 0, that will tell us our y-intercept. Happy with that? So the process is pretty simple. The only thing that makes this a little bit more challenging, and particularly when we're trying to find our gradient with our equations, Jake, what do you reckon makes it easier? Finding our gradient when we're looking at an equation. So if you look at, for example, question 3, or maybe not 3, look at question 4, for example. Who can tell me the gradient of that one very quickly?
-2. Is it 1?
What's the gradient of question 4?
Is it 1 or -2?
Neither. No. I haven't heard the right answer yet. No.
2 divided by 1.
Nope. Oh, what did you say?
I said 2 divided by 1.
Close. Brad, Nick's the closest. What did you say?
4 over 7.
4 over 7, nope. Oh, this is for the one on the second page, the one with the equation. 4 over 7 is correct, sorry. Second page. What's the gradient? What's the gradient? Why is it hard? I have to get it to this form first, don't I? Y equals mx plus c. So I need to get y by itself. So why don't we add 2y to both sides first? So just trust me, add 2y to both sides first on that equation. Add 2y to both sides. So what skill are we using here? We are rearranging. So I'm adding 2y to both sides. So now I should have an equation x plus 1, I think, equals 2y. Is y by itself yet? So how do I get y by itself? Divide both sides by 2. So now who can tell me what the gradient is? One over 2. Yep, a half. So our life is a lot easier when we're using equations when we get it into our general form. Y equals mx plus c. So on the back page, I'd recommend doing this first, getting it into this form first, and then finding my intercepts. One of the intercepts is easy if you don't do that first, but it doesn't matter. I don't care. Go the hard way. But it's much easier to find your gradient doing that. Cool? If I was really stuck, what else could I do to calculate my gradient? I could find any 2 points on my graph and go from there. Happy with that? The last the last little thing here is just a summary. So if we can use these skills with rearranging, we can determine any line's equation. I can show you any line, and you can tell me the equation of that line. You can sketch any line. I can give you any linear function. You should be able to sketch it. And you can find an x or y value at any point in time on a line, an x or a y value, providing you know the other one. So what skills do you need? Calculate an intercept, calculate a gradient, and rearranging. How do we rearrange again? What's the process? Reverse bomb dash. How do we cancel things? We don't just move stuff, we use opposite operations. Cool? Have a go at the back page. I'm going to come in and check homework too.